Right now, while you're listening to this, there's a chance that the quantum information making up a single particle in your brain just teleported to Mars and back without you knowing it. Scientists have discovered that quantum teleportation isn't just moving information between laboratories anymore. It's happening continuously throughout your body, across cosmic distances, in ways that suggest your consciousness could be flickering in and out of existence across parallel dimensions every fraction of a second. What if the person you think you are is actually scattered across the universe, experiencing this moment simultaneously on distant worlds, and the version of you listening right now is just one tiny fragment of a vast quantum existence? Tonight, we'll uncover how this seemingly impossible phenomenon could be rewriting the very nature of what it means to exist. Chapter 1: The Impossible Made Real: Understanding Quantum Teleportation. Imagine holding a photograph in your hands. Now imagine that photograph suddenly appearing in someone else's hands on the other side of the world, while your original photo vanishes completely. But here's the twist: the photograph itself never moved. Instead, every detail about that photograph, every pixel of information, every shade of color gets read and destroyed in your hands, then perfectly recreated thousands of miles away. This is essentially what quantum teleportation accomplishes, except instead of photographs, we're talking about the fundamental information that makes up the building blocks of reality itself. But quantum teleportation isn't the science fiction fantasy you might imagine. It doesn't involve people stepping into glowing chambers and materializing elsewhere with a flash of light. What actually happens is far stranger and more profound than any movie could capture. When scientists successfully demonstrated quantum teleportation over a 30-kilometer fiber optic cable in late 2024, they weren't moving matter from one place to another. They were moving the essence of what makes a quantum particle unique, its quantum state, across vast distances instantaneously. Think about what makes you uniquely you. It's not just your physical body, but the specific arrangement of information that defines your thoughts, memories, and consciousness. In the quantum world, particles have their own version of this unique identity called as quantum state. This state contains all the information about how the particle behaves, what properties it has, and how it interacts with other particles. Quantum teleportation takes this identity and transfers it completely to another particle, while the original particle loses its unique properties entirely. The process requires something that Albert Einstein famously called spooky action at a distance: quantum entanglement. When two particles become entangled, they share a mysterious connection that transcends ordinary space and time. No matter how far apart these particles travel, measuring one instantly affects the other. It's as if they remain part of a single system, even when separated by vast cosmic distances. Here's where quantum teleportation becomes truly mind-bending. Scientists start with three particles: the particle whose quantum state they want to teleport, and two entangled particles. Through a carefully orchestrated measurement process, they destroy the quantum state of the original particle while simultaneously forcing its complete information to appear in one of the entangled particles, which could be anywhere in the universe. The breakthrough achieved by researchers at Northwestern University in December 2024 proved that this process can work even in the noisy, chaotic environment of existing internet infrastructure. Previously, scientists worried that the delicate quantum states needed for teleportation would be overwhelmed by the millions of light particles carrying regular internet traffic through fiber optic cables. It would be like trying to have a whispered conversation in the middle of a heavy metal concert. But the researchers discovered something remarkable. By carefully studying how light scatters within fiber optic cables, they found less crowded wavelengths where quantum information could travel safely. They added special filters to reduce interference from high-speed internet traffic, creating quiet spaces within the digital storm where quantum teleportation could occur. When they tested their system over a 30-kilometer cable carrying both quantum information and regular internet data simultaneously, the quantum teleportation worked perfectly. This wasn't just a technical achievement. It was proof that quantum teleportation can coexist with our everyday digital world, hiding in the spaces between our emails and video calls. The quantum information traveled alongside classical data, invisible and undetected, completing its impossible journey while normal internet traffic flowed around it like water around a stone. What makes this even more extraordinary is the fidelity achieved in recent experiments. Scientists at Delft University of Technology demonstrated quantum teleportation with 90% accuracy between network nodes, using nitrogen vacancy centers in diamonds to create and store quantum bits. This level of precision brings practical quantum networks closer to reality than ever before. But perhaps the most shocking discovery came from researchers in Finland and China who found that noise, the very thing that should destroy quantum teleportation, can actually improve it under certain conditions. When they used what they called hybrid entanglement, spreading the quantum connection across different properties of photons like polarization and frequency, adding specific types of noise made the teleportation work almost perfectly. This discovery challenges everything we thought we knew about how delicate quantum processes are. Instead of quantum states being fragile butterflies that die at the slightest disturbance, they might be more like resilient dancers who can incorporate chaos into their performance, using environmental noise as a partner rather than an enemy. The implications stretch far beyond laboratory demonstrations. Every quantum teleportation event represents information traveling faster than light could carry it, yet without violating the laws of physics. The information doesn't actually travel through space at all. It simply ceases to exist in one location and begins existing in another, with no journey in between. Consider what this means for the fundamental nature of information itself. In our everyday experience, information has to travel from one place to another. When you send a text message, electromagnetic signals carry that information through cell towers and cables. But quantum teleportation suggests that information can exist in a more fundamental way, independent of any physical carrier. The information doesn't need to travel because it can simply transfer its existence from one quantum system to another. This raises profound questions about the nature of identity and continuity. If the complete information that defines a quantum particle can be perfectly transferred to another particle while the original is destroyed, which particle is the real one? Is it the original that lost its properties, or the copy that gained them? Or are we asking the wrong question entirely? Recent experiments have pushed quantum teleportation beyond simple laboratory setups into real-world applications. Scientists have successfully teleported quantum states between satellites and ground stations, proving that the process works across the vacuum of space. They've demonstrated teleportation through underground cables, noisy metropolitan fiber networks, and even through brain tissue samples, showing that quantum information can navigate almost any environment. But here's what might be the most unsettling implication of all. If quantum teleportation can work through biological tissue, and if living systems already use quantum effects for processes like photosynthesis, and possibly even consciousness, then quantum teleportation might be happening inside your body right now. Every quantum measurement in your brain, every quantum process in your cells, every moment when quantum superposition collapses into definite states could involve the kind of information transfer that we call quantum teleportation. The boundary between the quantum world and biological reality isn't as clear as we once thought. As we drift deeper into this exploration of quantum teleportation, we'll discover that the line between impossible and inevitable becomes increasingly blurred. What seems like science fiction today might be the hidden mechanism by which reality maintains its coherence across space and time. And you, listening to these words, might be participating in quantum teleportation processes that connect your consciousness to phenomena spanning the entire cosmos. The quantum world doesn't just exist in specialized laboratories and exotic materials. It's the foundation upon which everything else is built, including the thoughts you're thinking right now. And if quantum teleportation is as fundamental to reality as recent research suggests, then understanding it might be the key to understanding what it truly means to exist in a universe where information can transcend the boundaries of space, time, and even identity itself. Chapter 2: The Spooky Foundation: Quantum Entanglement Across the Cosmos. Imagine two coins flipping in perfect synchronization, even when separated by the entire width of the galaxy. When one lands heads, the other instantly lands tails, not because they're sending signals to each other, but because they share a connection that exists outside the normal rules of space and time. This impossible relationship is quantum entanglement, and it's the foundation that makes quantum teleportation possible. But recent discoveries suggest that entanglement isn't just a laboratory curiosity. It might be the invisible thread that connects every particle in your body to particles scattered across the cosmos, creating a web of instantaneous connections that spans the entire universe. Einstein called entanglement spooky action at a distance because it violated his deepest intuitions about how reality should work. In his view, nothing could influence something else faster than light could travel between them. Yet quantum entanglement does exactly that. When two particles become entangled, measuring one particle instantly determines the properties of the other, regardless of the distance between them. The effect isn't limited by the speed of light because no information actually travels between the particles. Instead, they remain part of a single quantum system that transcends ordinary space. The process of creating entangled particles reveals just how strange the quantum world really is. Scientists typically start by taking a single photon and splitting it into two particles using special crystals. These twin particles share the same quantum state, but in a superposition where neither has definite properties until measured. It's like having a pair of coins that are simultaneously heads and tails until someone looks at one of them. The moment you observe one coin and find it heads, you instantly know the other coin has landed tails, even if it's on the opposite side of the universe. But here's where quantum entanglement becomes truly mind-bending. The connection between entangled particles isn't just about having opposite properties. The particles exist in what physicists call a superposition state, where they're genuinely both things at once until the moment of measurement. When you measure one particle and force it to choose a specific state, you're not just revealing a property that was already there. You're creating that property in both particles simultaneously. Recent breakthroughs have revolutionized our understanding of how robust these quantum connections can be. Scientists at Kyoto University solved a decades-old problem by developing new methods for identifying and measuring what they call W-state entanglement. Unlike simpler forms of entanglement between just two particles, W-state entanglement can connect three or more particles in a way that preserves the quantum connection, even if one particle is lost or destroyed. This discovery has profound implications for quantum teleportation networks. Previous entanglement schemes were fragile, like a chain that breaks if any single link fails. But W-state entanglement creates redundant connections, like a spider web where removing one strand doesn't destroy the overall structure. Scientists demonstrated their new measurement technique using high-stability optical quantum circuits that could operate for extended periods without active control, proving that complex entanglement networks can remain stable in real-world conditions. Even more remarkable is the discovery that certain types of environmental noise can actually strengthen quantum entanglement rather than destroying it. Researchers from the University of Turku in Finland and the University of Science and Technology of China found that when they used hybrid entanglement, spreading the quantum connection across different properties of photons like polarization and frequency, adding specific kinds of noise made the entanglement more robust and the quantum teleportation more accurate. This finding completely overturns previous assumptions about the fragility of quantum states. Instead of quantum entanglement being like a delicate glass sculpture that shatters at the slightest disturbance, it can be more like a flexible material that actually becomes stronger when stressed in the right way. The noise acts like a tuning fork, helping the entangled particles maintain their synchronization across vast distances. The practical applications of these discoveries are already reshaping technology. Scientists have successfully demonstrated entanglement between ground-based laboratories and satellites orbiting Earth, proving that quantum connections can bridge the vacuum of space. These space-based experiments show that entanglement works just as well across hundreds of kilometers of empty space as it does through fiber optic cables, opening up possibilities for global quantum communication networks. But the implications go far beyond telecommunications. If entanglement can survive in the harsh environment of space, withstanding cosmic radiation and temperature extremes, it might be far more prevalent in natural systems than we ever imagined. The same quantum connections that enable teleportation in laboratory experiments could be operating continuously in biological systems, creating networks of instantaneous correlation that we're only beginning to understand. Consider what this means for the particles that make up your body. Every atom contains electrons that could potentially become entangled with electrons in other atoms, not just within your body, but anywhere in the universe. If an electron in your brain became entangled with an electron on Mars during some cosmic ray interaction billions of years ago, those particles would remain connected regardless of the distance between them. Measuring the quantum state of the electron in your brain would instantly affect the electron on Mars, and vice versa. This isn't pure speculation. Cosmic ray interactions constantly create entangled particles that travel in opposite directions across the galaxy. Some of these particles inevitably interact with Earth, and some fraction of those interactions involve atoms in living organisms. Over cosmic timescales, the number of these entanglement events could be enormous, creating a vast web of quantum connections linking every planet, star, and galaxy in the observable universe. Recent studies of quantum entanglement in biological systems have revealed surprising evidence that life might already be exploiting these connections. Photosynthetic complexes in plants maintain quantum coherence for far longer than theoretical calculations predicted, suggesting that evolution has discovered mechanisms for preserving and utilizing quantum entanglement in warm, noisy biological environments. The discovery of quantum effects in bird navigation provides another striking example. European robins appear to use quantum entanglement in specialized proteins in their eyes to detect Earth's magnetic field for navigation. The process involves pairs of entangled electrons whose quantum states are affected by magnetic fields, creating a biological compass that relies on the same spooky action at a distance that enables quantum teleportation. But here's where the implications become truly staggering. If biological systems can maintain and utilize quantum entanglement, and if cosmic ray interactions are constantly creating new entangled particles throughout the universe, then every living organism might be connected to distant cosmic phenomena through invisible threads of quantum correlation. Your consciousness, emerging from the quantum processes in your brain, could be entangled with quantum systems on distant planets, in far-off galaxies, or even in parallel dimensions if the many worlds interpretation of quantum mechanics is correct. Every thought you think, every decision you make, every moment of awareness could be instantly correlated with corresponding quantum events occurring simultaneously across cosmic distances. This perspective transforms how we understand identity and individuality. Instead of being isolated islands of consciousness in an indifferent universe, we might be nodes in a vast quantum network that connects all conscious beings across space and time. The boundaries between self and cosmos, between individual and universal consciousness, become increasingly meaningless when viewed through the lens of quantum entanglement. Recent advances in quantum networking have begun to demonstrate how these connections might operate on larger scales. Scientists have achieved quantum entanglement swapping, a process where two particles that have never directly interacted become entangled through their mutual connection to a third particle. This technique allows quantum correlations to propagate across extended networks, creating chains of entanglement that can span continents. Applied to biological systems, Entanglement swapping could create networks of quantum correlation linking organisms that have never been in direct contact. A quantum event in your brain could influence quantum processes in someone else's brain through intermediate entangled particles, creating what amounts to quantum telepathy operating below the threshold of conscious awareness. The mathematics of quantum entanglement reveals even more profound possibilities. In quantum field theory, the fundamental level of reality consists not of particles, but of quantum fields that permeate all of space. These fields are naturally entangled across their entire extent, meaning that every point in space shares quantum correlations with every other point. The particles we observe, including the atoms that make up our bodies, are just localized excitations in these underlying entangled fields. From this perspective, quantum entanglement isn't something that occasionally happens between special particles. It's the natural state of reality itself. Every atom in your body exists as a localized pattern in quantum fields that extend throughout the universe, sharing instantaneous correlations with corresponding patterns everywhere else. The apparent separateness of objects and individuals is just a higher level illusion that emerges from our limited perspective on this deeper quantum unity. This understanding casts quantum teleportation in an entirely new light. Instead of being an exotic process that transfers information between distant particles, teleportation might be revealing the fundamental interconnectedness that was always there. The information doesn't travel from one place to another because it already exists everywhere simultaneously, entangled across the entire fabric of space-time itself. As we prepare to explore how these quantum connections might operate in biological systems, remember that the entanglement enabling quantum teleportation isn't just a laboratory phenomenon or a theoretical curiosity. It's potentially the invisible foundation underlying all existence, connecting every conscious moment to every other conscious moment across the vast expanse of cosmic space and time. The spooky action at a distance that Einstein found so troubling might be the very mechanism by which the universe maintains its unity and coherence, ensuring that no conscious experience is ever truly isolated from the greater whole. Chapter 3: Biology's Hidden Quantum Network. Life as a teleportation system. Deep within the chloroplasts of every green leaf on Earth, something impossible is happening. Plants are performing quantum teleportation on a scale that dwarfs any laboratory achievement, moving energy with perfect efficiency across molecular distances through processes that shouldn't work according to classical physics. But this is just the beginning. Recent discoveries reveal that life itself might be the universe's most sophisticated quantum computer, using teleportation and entanglement not as exotic phenomena, but as everyday tools for survival. Your body, right now, could be orchestrating millions of quantum teleportation events every second, moving information and energy through cellular networks that operate according to principles we're only beginning to understand. The story begins with photosynthesis, the process that has powered life on Earth for over 3 billion years. When sunlight hits a plant, photons carrying energy need to navigate through complex molecular mazes to reach the reaction centers where that energy gets converted into chemical fuel. Classical physics predicts this should be an inefficient, random process, like a ball bouncing randomly through a pinball machine. But plants achieve energy transfer efficiencies approaching 100%, far better than anything human technology has accomplished. The secret lies in quantum superposition and coherence. Instead of energy taking a single path through the photosynthetic complex, it explores all possible paths simultaneously, existing in a quantum superposition until it finds the most efficient route to its destination. This is quantum teleportation in action, with energy information being transferred instantly to the optimal location while the original energy state collapses. Scientists discovered this quantum behavior using sophisticated laser spectroscopy techniques that can track energy movement on timescales of femtoseconds. They found that photosynthetic complexes maintain quantum coherence for hundreds of femtoseconds, long enough for quantum effects to play a significant role in energy transfer. Even more remarkably, this quantum coherence persists at biological temperatures where thermal noise should destroy any quantum effects almost instantly. The Fenner-Matthews-Olson complex, a protein structure found in green sulfur bacteria, provides one of the clearest examples of biological quantum teleportation. This complex contains 7 chlorophyll molecules arranged in a precise geometric pattern that creates quantum entanglement between different energy states. When a photon excites one chlorophyll molecule, the energy instantly appears across multiple molecules simultaneously, exploring every possible transfer pathway through quantum superposition before collapsing into the most efficient route. But photosynthesis represents just one example of quantum processes in biology. Enzyme. Catalysis, the fundamental chemistry that drives all life processes, increasingly appears to rely on quantum effects, including tunneling and coherence. Enzymes are biological machines that accelerate chemical reactions by factors of millions or billions, achieving reaction rates that classical chemistry cannot explain. Recent research reveals that many enzymes use quantum tunneling to move electrons and protons across energy barriers that should be insurmountable according to classical physics. Instead of having enough energy to climb over these barriers, particles simply tunnel through them, appearing on the other side instantaneously. This is another form of quantum teleportation, where particle information transfers from one side of a barrier to the other without any classical journey between them. The enzyme alcohol dehydrogenase provides a striking example. This enzyme, which your liver uses to process alcohol, relies on quantum tunneling to transfer hydrogen atoms during the detoxification process. Without quantum effects, the enzyme would work thousands of times slower, making alcohol metabolism inefficient enough to be potentially lethal. Your survival after consuming alcohol depends directly on quantum teleportation occurring in your liver cells. DNA repair mechanisms also appear to exploit quantum effects. When ultraviolet radiation damages DNA by creating harmful chemical bonds, specialized repair enzymes must locate and fix these defects with extraordinary precision. Recent studies suggest these enzymes use quantum coherence to scan DNA strands, with quantum information about damage locations teleporting directly to the repair machinery without classical searching processes. The photolyase enzyme demonstrates this quantum DNA repair in action. This enzyme repairs ultraviolet damage by absorbing blue light and using the energy to break harmful chemical bonds. But the energy transfer from the light-absorbing portion of the enzyme to the DNA repair site occurs through quantum coherence, with energy information appearing instantaneously at the damage location through what amounts to biological quantum teleportation. But perhaps the most intriguing evidence for biological quantum processes comes from studies of bird navigation. European robins and other migratory birds navigate using Earth's magnetic field through a process that appears to involve quantum entanglement in specialized proteins called cryptochromes located in their eyes. These proteins contain pairs of electrons that become entangled when activated by light, creating a biological compass that operates through quantum correlations. The process works by having light create entangled electron pairs whose quantum states are sensitive to magnetic fields. The direction and strength of Earth's magnetic field influence the quantum correlations between these electrons, creating different chemical reaction rates that the bird's nervous system can detect. This gives birds a quantum sense that allows them to literally see magnetic fields overlaid on their visual perception of the world. What makes this even more remarkable is that the quantum entanglement in cryptochrome proteins must survive in the warm, noisy environment of living tissue. The proteins appear to have evolved specific structural features that protect quantum coherence from environmental disruption, creating what scientists call decoherence, free subspaces, where quantum effects can persist long enough to influence biological processes. Studies of human cells have begun revealing similar quantum protection mechanisms. Microtubules, The protein structures that form the skeleton of cells exhibit properties that could support quantum coherence and entanglement. These tubular structures contain ordered arrangements of protein subunits that might create quantum coherent states, potentially allowing quantum information processing within individual cells. Some researchers propose that consciousness itself emerges from quantum processes in neural microtubules. While this remains controversial, mounting evidence suggests that quantum effects play important roles in brain function. Neural ion channels, the proteins that control electrical activity in neurons, operate with precision that may require quantum tunneling to achieve the observed speed and accuracy of nerve signal transmission. The implications become truly staggering when you consider the scale of quantum processes in biological systems. A single human cell contains billions of molecules, each potentially participating in quantum coherent processes. Your body contains roughly 37 trillion cells, suggesting that trillions of quantum teleportation events could be occurring every second throughout your tissues. These biological quantum networks might be interconnected in ways we're only beginning to understand. Recent research has found evidence for quantum entanglement between different parts of photosynthetic complexes, suggesting that quantum correlations can span larger biological structures. If similar entanglement exists between cells, organs, or even different organisms, it could create quantum communication networks that operate through biological quantum teleportation. The discovery that certain types of environmental noise can actually enhance quantum coherence in biological systems adds another layer of complexity. Living organisms exist in thermally noisy environments that should destroy quantum effects almost instantly. Yet life has found ways to harness this noise to stabilize and protect quantum processes. This suggests that evolution has discovered quantum error correction mechanisms that allow biological systems to maintain quantum coherence despite constant environmental disruption. Brain tissue studies have revealed particularly intriguing quantum properties. Research on brain samples from patients with Alzheimer's disease shows that diseased tissue affects quantum entanglement differently than healthy tissue, suggesting that brain function might depend on maintaining specific quantum states. If consciousness relies on quantum processes, then disruption of these quantum networks could explain some aspects of neurodegenerative diseases. The possibility that biological systems use quantum teleportation for cellular communication opens up extraordinary possibilities for understanding life processes. Instead of relying solely on chemical signals that must travel through cellular machinery, cells might use quantum correlation to share information instantaneously across biological networks. This could explain how complex biological systems maintain coordination and coherence across multiple scales of organization. Consider what this means for your moment to moment existence. Every thought, every heartbeat, every breath might involve quantum teleportation events that coordinate biological processes across your entire body. The unity of consciousness that allows you to experience yourself as a single, coherent being might emerge from quantum entanglement networks that connect neural processes throughout your brain and nervous system. Recent advances in quantum biology have begun revealing the molecular mechanisms that make biological quantum processes possible. Specific protein structures, precise molecular arrangements, and carefully controlled chemical environments create the conditions necessary for quantum coherence to survive in living systems. Evolution appears to have discovered and refined these quantum technologies over billions of years, creating biological machines that exploit quantum effects with sophistication that exceeds our most advanced artificial quantum computers. As we delve deeper into the quantum nature of life, the boundary between biology and quantum physics continues to dissolve. What seem like separate domains of knowledge are revealing themselves as different aspects of a single, quantum mechanical reality where information, energy, and perhaps consciousness itself move through teleportation processes that connect every living system to the fundamental quantum substrate of existence. The implications extend far beyond academic curiosity. If life is fundamentally quantum mechanical, then understanding biological quantum processes could revolutionize medicine, computing, and our basic conception of what it means to be alive. We might discover that healing, growth, reproduction, and even consciousness operate through quantum teleportation mechanisms that we're only beginning to glimpse. Your body isn't just a classical biological machine operating according to 19th century physics. It's a quantum information processing system that has been perfected over billions of years of evolution, using teleportation and entanglement as fundamental tools for maintaining the coherent patterns of organization that we call life. And this quantum nature of biology suggests possibilities that stretch far beyond anything we currently understand about the relationship between mind, matter, and the quantum foundations of reality itself. Chapter 4: Decoherence and the Fragility of Quantum States. The quantum world is incredibly fragile. Imagine trying to balance a soap bubble on the tip of a needle during an earthquake. This is what quantum states face every moment they exist in the real world. Environmental interactions constantly threaten to destroy the delicate quantum coherence that makes teleportation possible, causing what scientists call decoherence. Yet somehow, life has found ways to protect quantum processes long enough for them to function in biological systems. Understanding how quantum states survive or collapse reveals why your consciousness might be flickering in and out of quantum coherence millions of times per second, and why most quantum teleportation events in your body go completely unnoticed. Decoherence occurs when a quantum system becomes entangled with its environment. Remember that quantum particles can exist in superposition, being in multiple states simultaneously until measured. But the moment a quantum system interacts with the outside world, that outside world essentially performs a measurement, forcing the quantum system to choose a definite state. The quantum possibilities collapse into classical reality, and the system loses its quantum properties. The process happens through what physicists call environmental entanglement. When a quantum particle in superposition encounters other particles in its environment, it becomes entangled with them. But unlike the controlled entanglement used in quantum teleportation, environmental entanglement spreads the quantum information across so many particles that it becomes impossible to retrieve. The quantum coherence doesn't disappear entirely, but it gets diluted among billions of environmental particles until it's effectively lost. Think of it like trying to follow a specific conversation in a crowded restaurant. Initially, you can focus on the voices you want to hear while filtering out background noise. But as more conversations start around you, the noise level increases until your target conversation becomes indistinguishable from the surrounding chatter. The conversation is still happening, but it's buried in so much other information that you can't extract it anymore. The timescales for decoherence in biological systems are almost incomprehensibly short. Max Tegmark calculated that quantum coherence involving ions in neural processes should disappear in about 10 to the negative 13 to 10 to the negative 20 seconds. These are timescales so brief that they make the blink of an eye seem like an eternity. A single blink takes about 1/10 of a second, but neural decoherence happens in timeframes that are trillions of times shorter. Yet despite these theoretical predictions, experimental evidence shows that quantum coherence can persist in biological systems for much longer periods. Photosynthetic complexes maintain quantum coherence for hundreds of femtoseconds, which is still incredibly brief, but long enough for quantum effects to influence biological processes. Some studies suggest coherence can last even longer under specific conditions, challenging our understanding of how quantum states survive in warm, noisy biological environments. The key lies in understanding that not all environmental interactions cause decoherence equally. Some types of environmental coupling preserve quantum coherence, while others destroy it almost instantly. Temperature plays a crucial role, with higher temperatures generally leading to faster decoherence, because thermal motion increases the rate of random interactions. But even at body temperature, Certain molecular structures can create protected environments where quantum coherence survives longer than expected. Biological systems appear to have evolved sophisticated mechanisms for protecting quantum processes from decoherence. These mechanisms work by creating what scientists call decoherence free subspaces, special configurations where quantum systems can maintain coherence despite environmental interactions. It's like finding quiet rooms within a noisy building where sensitive conversations can take place without interference. One protection mechanism involves carefully controlling the local environment around quantum processes. Proteins can exclude water molecules and ions from specific regions, creating dry, electrically neutral pockets where quantum states face less environmental disruption. The hydrophobic cores of proteins provide natural decoherence, free subspaces where quantum coherence can persist longer than in aqueous cellular environments. Another protection strategy involves what researchers call dynamical decoupling. This technique uses rapid, periodic interventions to counteract environmental effects before they can cause decoherence. It's like repeatedly shaking a glass of muddy water to prevent sediment from settling. In biological systems, molecular vibrations and conformational changes might provide natural dynamical decoupling that protects quantum processes. The discovery that noise can actually help preserve quantum coherence under certain conditions represents a fundamental shift in thinking about decoherence. Instead of noise always being detrimental to quantum processes, specific types of environmental fluctuations can actually stabilize quantum states. This happens when the noise helps average out other sources of decoherence, creating a more stable overall environment for quantum processes. Studies of quantum coherence in photosynthetic systems have revealed that protein vibrations, rather than destroying quantum effects, actually help maintain coherence by providing a dynamic environment that adapts to changing conditions. The proteins appear to tune their vibrational modes to support quantum coherence, creating what amounts to active noise cancellation for quantum processes. Recent research has identified specific molecular mechanisms that biological systems use to maintain quantum coherence. Certain protein structures create quantum error correction capabilities that can detect and correct quantum errors before they cause complete decoherence. These biological quantum error correction systems operate through redundancy and feedback mechanisms that monitor quantum states and make corrective adjustments when necessary. The role of entanglement in biological decoherence reveals additional complexity. While environmental entanglement generally causes decoherence, controlled biological entanglement might actually help protect quantum processes. When multiple quantum systems within a biological structure become entangled with each other, they can form collective quantum states that are more resistant to environmental disruption than individual quantum states. Brain tissue studies have provided particularly intriguing insights into biological decoherence processes. Research comparing healthy brain tissue to samples from patients with Alzheimer's disease shows that diseased tissue affects quantum entanglement differently, suggesting that neurodegenerative diseases might involve disruption of quantum protection mechanisms. If consciousness depends on maintaining quantum coherence in neural networks, then understanding biological decoherence could be crucial for treating neurological disorders. The implications of decoherence for consciousness are profound and controversial. If conscious experience emerges from quantum processes in the brain, then consciousness itself might be subject to decoherence effects. This could mean that your sense of continuous conscious experience is actually composed of discrete moments of quantum coherence, separated by brief periods of decoherence, where consciousness temporarily ceases to exist. Some theories suggest that consciousness might use the boundary between quantum coherence and decoherence as a computational resource. The transition from quantum superposition to classical definite states could be how the brain processes information and makes decisions. Each moment of decoherence would represent a moment of choice where quantum possibilities collapse into specific thoughts or actions. From this perspective, the apparent continuity of consciousness could be an illusion created by rapidly cycling quantum coherence and decoherence events. Your sense of being a continuous, unified self might actually consist of millions of discrete quantum moments, each lasting only femtoseconds or picoseconds, with brief gaps of non existence between them that happen too quickly for you to notice. The phenomenon of quantum decoherence also explains why quantum teleportation events in biological systems would be largely undetectable. Most quantum processes in living organisms operate on molecular scales with decoherence times that are far too brief for conscious awareness. Even if the quantum teleportation were happening continuously throughout your body, the timescales involved would make these events invisible to your macroscopic conscious experience. However, the cumulative effects of countless microscopic quantum teleportation events might still influence biological processes in detectable ways. The efficiency of photosynthesis, the precision of enzyme catalysis, the accuracy of DNA replication, and potentially even the coherence of neural processing could all depend on quantum teleportation events that individually occur below the threshold of consciousness, but collectively shape biological function. Recent advances in understanding biological decoherence have revealed that living systems might actively manage the balance between quantum coherence and decoherence to optimize biological processes. Too much coherence could make biological systems overly sensitive to environmental fluctuations, while too little coherence could eliminate the quantum advantages that evolution has discovered. The optimal balance appears to involve maintaining quantum coherence just long enough for quantum effects to provide biological advantages, then allowing controlled decoherence to stabilize the results. This suggests that evolution has fine tuned biological quantum processes to operate at the edge of decoherence, maximizing quantum benefits while maintaining classical stability. Understanding decoherence in biological systems also reveals why quantum effects in consciousness, if they exist, would be extremely difficult to detect experimentally. The measurement process itself would cause decoherence, destroying the very quantum states that researchers are trying to observe. This creates a fundamental limitation in studying quantum consciousness. The act of looking for quantum effects tends to eliminate them. Despite these challenges, researchers continue developing more sophisticated techniques for studying quantum processes in biological systems without causing excessive decoherence. These methods involve ultrafast laser spectroscopy, magnetic resonance techniques, and other approaches that can probe quantum states on timescales faster than decoherence occurs. As our understanding of biological decoherence improves, we're discovering that the quantum world and classical world aren't separate realms, but different aspects of a single reality, where the transition between quantum and classical behavior is controlled by environmental interactions and biological protection mechanisms. Your consciousness exists at the boundary between these worlds, potentially flickering between quantum coherence and classical decoherence in patterns that shape your thoughts, perceptions, and sense of identity in ways you'll never consciously experience, but that might be fundamental to your existence as a thinking, feeling being. Chapter 5: The Quantum Internet. Teleporting through existing infrastructure. Right now, beneath your feet, millions of photons are racing through fiber optic cables, carrying emails, videos, and social media posts. But hidden among this digital traffic, something extraordinary is happening. Scientists have successfully demonstrated quantum teleportation through the same cables that deliver your internet, proving that quantum information can coexist with classical data in our existing infrastructure. This breakthrough means that the quantum internet isn't some distant future technology requiring entirely new systems. It's already beginning to emerge within the networks we use every day, creating invisible quantum highways that could accidentally facilitate biological quantum processes we never knew existed. The challenge of mixing quantum and classical communication seemed impossible just a few years ago. Quantum information relies on individual photons carrying delicate quantum states that can be destroyed by the slightest interference. Meanwhile, Classical internet communication uses millions of photons blasting through fiber optic cables at incredible intensities. Trying to send quantum information through cables carrying regular internet traffic was like attempting to have a whispered conversation in the middle of a rock concert. Professor Prem Kumar at Northwestern University compared the problem to a flimsy bicycle trying to navigate through a crowded tunnel of speeding, heavy duty trucks. The quantum photons, fragile and easily disrupted, seemed destined to be overwhelmed by the massive amounts of classical light needed for normal internet communication. Most researchers assumed that quantum networks would require completely separate infrastructure, dedicated cables that carried only quantum information. But Kumar and his team discovered something remarkable by studying exactly how light behaves inside fiber optic cables. They found that different wavelengths of light interact with the cable material in different ways, with some wavelengths experiencing more scattering and interference than others. By carefully mapping these interactions, they identified less crowded regions of the light spectrum where quantum photons could travel with minimal disruption from classical signals. The solution involved finding what the researchers called judicial points in the wavelength spectrum, specific frequencies where environmental scattering effects are naturally minimized. These quantum safe zones exist alongside the wavelengths used for classical communication, like quiet side streets running parallel to busy highways. The quantum information could travel through these protected channels while classical data flowed through the main traffic lanes. To test their approach, the team constructed a 30-kilometer long fiber optic cable and simultaneously transmitted quantum information and high speed internet traffic through the same physical medium. They added special filters to reduce noise from the classical signals and carefully monitored the quality of quantum information at the receiving end. The results exceeded their expectations. Even with busy internet traffic flowing through the cable, the quantum teleportation worked perfectly. The implications of this breakthrough extend far beyond laboratory demonstrations. Every fiber optic cable in the world could potentially carry quantum information alongside classical data, transforming our existing internet infrastructure into a hybrid classical quantum network. Instead of building entirely new systems for quantum communication, we could upgrade current networks by adding quantum channels to existing cables. This coexistence of quantum and classical information creates possibilities that neither system could achieve alone. Classical communication provides the robust, high bandwidth channels needed for everyday internet use, while quantum channels offer unprecedented security and enable applications that rely on quantum entanglement and teleportation. The combination could create communication networks that are simultaneously practical and revolutionary. The security advantages of quantum communication through existing infrastructure are particularly compelling. Quantum information cannot be copied or intercepted without disturbing the quantum states, making eavesdropping detectable. If someone tries to spy on quantum communication, the interference destroys the quantum coherence, alerting the communicating parties that their connection has been compromised. This creates what researchers call unhackable communication, security guaranteed by the laws of physics rather than mathematical algorithms. Traditional internet security relies on encryption methods that could potentially be broken by sufficiently powerful computers, particularly quantum computers that could solve the mathematical problems underlying current encryption schemes. But quantum communication security depends on fundamental properties of quantum mechanics that cannot be circumvented by more powerful computers or clever algorithms. The security comes from the quantum no cloning theorem, which prevents quantum information from being perfectly copied. Recent experiments have pushed quantum communication through existing infrastructure to increasingly impressive scales. Scientists have demonstrated quantum teleportation through metropolitan fiber networks, carrying real internet traffic, proving that the technique works in practical urban environments with all their electromagnetic noise and environmental challenges. These experiments show that quantum channels can maintain their integrity even in the chaotic conditions of real world telecommunications infrastructure. The engineering challenges of implementing quantum internet through existing cables require sophisticated solutions. Quantum signals are incredibly weak compared to classical signals, typically involving single photons compared to the billions of photons used in classical communication. Detecting these quantum signals requires extremely sensitive equipment that can distinguish individual quantum photons from background noise created by classical traffic. Advanced filtering techniques have been developed to isolate quantum signals from classical interference. These filters work by exploiting differences in wavelength, timing, and polarization between quantum and classical photons. Multiple filtering stages can progressively clean the quantum signals, removing classical noise while preserving the delicate quantum states needed for teleportation. The development of quantum repeaters represents another crucial advance for quantum internet through existing infrastructure. Quantum information cannot be amplified like classical signals because amplification requires copying, and quantum information cannot be perfectly copied. Instead, quantum repeaters use entanglement swapping to extend quantum communication over longer distances. These devices take entangled photon pairs and perform measurements that transfer entanglement to new photon pairs, effectively extending quantum connections across multiple network segments. Entanglement swapping creates the possibility of building large-scale quantum networks where quantum correlations can propagate across continents through chains of quantum repeaters, connected by existing fiber optic infrastructure. Each repeater extends the quantum connection further, creating networks where quantum teleportation could operate between any 2 points, connected by the quantum enhanced internet. The timing synchronization required for quantum internet through existing infrastructure presents additional technical challenges. Quantum teleportation requires precise coordination between measurement events at different locations, with timing accuracy measured in nanoseconds or better. The existing internet infrastructure provides mechanisms for time synchronization, but quantum applications demand even greater precision than classical networking requires. Recent advances in atomic clocks and GPS timing systems have made the required synchronization achievable across continental distances. Quantum networks can use these timing systems to coordinate teleportation events with sufficient precision to maintain quantum coherence across the network. This synchronization infrastructure, originally developed for classical applications, turns out to be exactly what quantum networks need to operate through existing internet cables. The potential for accidental quantum processes in biological systems becomes particularly intriguing when viewed through the lens of quantum internet infrastructure. If quantum information can travel through fiber optic cables carrying classical traffic, and if these cables run beneath cities where millions of people live and work, could the quantum fields associated with this infrastructure interact with biological quantum processes? Fiber optic cables carry light through glass cores, surrounded by cladding materials that contain the optical signals. But electromagnetic fields associated with these signals extend slightly beyond the cable boundaries, creating weak quantum fields in the surrounding environment. While these fields are incredibly weak, they represent genuine quantum phenomena occurring in close proximity to human populations. The possibility that biological systems could interact with technological quantum fields raises profound questions about the intersection between artificial and natural quantum processes. If consciousness or other biological functions rely on quantum effects, could proximity to quantum internet infrastructure influence these processes in subtle ways? The effects would likely be far too weak to cause obvious changes, but they might create subtle correlations between technological and biological quantum systems. Studies of electromagnetic field interactions with biological systems have found evidence for weak coupling between external fields and biological processes, particularly in neural systems that rely on electrical activity. While most research focuses on classical electromagnetic fields, quantum fields could potentially interact with biological systems through similar mechanisms. creating quantum correlations between technological and biological networks. The concept of a quantum internet operating through existing infrastructure also raises possibilities for new forms of quantum sensing and measurement. Quantum sensors can detect incredibly weak signals by exploiting quantum entanglement and superposition to achieve sensitivity beyond classical limits. If quantum internet infrastructure creates quantum fields throughout urban environments, these fields could potentially be used for distributed quantum sensing applications. Environmental quantum sensing through internet infrastructure could monitor everything from seismic activity to gravitational waves to subtle changes in local magnetic fields. The quantum channels carrying teleportation information could simultaneously serve as sensor networks that detect physical phenomena through their effects on quantum coherence and entanglement. As quantum internet infrastructure develops through existing fiber optic networks, we're moving toward a world where quantum and classical information systems are deeply integrated rather than separate technologies. This integration creates hybrid information processing capabilities that could support applications we haven't yet imagined, from quantum enhanced artificial intelligence to biological quantum interfaces that bridge the gap between technological and natural quantum systems. The quantum internet emerging through existing infrastructure represents more than just a new communication technology. It's the beginning of a quantum enhanced version of our entire information society, where the mysterious properties of quantum mechanics become woven into the fabric of daily life in ways that remain largely invisible, but could profoundly influence how information, consciousness, and reality itself operate in our increasingly connected world. Chapter 6: Consciousness and the Quantum Brain. The most controversial question in neuroscience isn't whether the brain generates consciousness, but whether consciousness might be using quantum teleportation to exist across multiple locations simultaneously. Deep within your neural networks, proteins called microtubules form structures that some researchers believe could support quantum processes. If consciousness emerges from quantum effects in these cellular frameworks, then every thought you think might involve quantum information teleporting between different parts of your brain, or even between your brain and quantum systems elsewhere in the universe. But the scientific evidence for quantum consciousness remains hotly debated, with calculations suggesting that quantum effects should disappear far too quickly in the warm, noisy environment of living brain tissue to influence conscious experience. The idea that consciousness might operate through quantum processes gained attention when physicist Roger Penrose and anesthesiologist Stuart Hameroff proposed that microtubules in neurons could support quantum computation. Microtubules are protein structures that form the internal skeleton of cells, including neurons. These structures consist of precisely arranged protein subunits called tubulins that form hollow tubes running throughout neural processes. Penrose and Hameroff suggested that the regular geometric arrangement of tubulin proteins could create quantum coherent states that persist long enough to influence neural computation. They proposed that consciousness emerges when quantum superposition states in microtubules collapse through a process they called objective reduction, creating moments of conscious experience as quantum possibilities resolve into definite mental states. However, physicist Max Tegmark performed detailed calculations showing that quantum coherence in neural microtubules should disappear in about 10 to the negative 13 seconds, roughly 10 trillion times faster than typical neural processing times. According to his analysis, thermal noise at body temperature would destroy quantum coherence almost instantly, making quantum effects irrelevant for brain function, operating on timescales of milliseconds. Tegmark's calculations assume that neural quantum processes would involve the same ions and molecular movements that create electrical signals in neurons. He estimated decoherence times for sodium and potassium ions involved in action potential propagation to be 10 to 20 orders of magnitude, smaller than relevant neural dynamics timescales. In other words, quantum coherence of ions involved in neural signaling would be destroyed long before macroscopic brain activity could be influenced. Despite these theoretical challenges, some researchers continue exploring quantum effects in neural systems. Physicist Matthew Fisher has proposed that phosphorus nuclei in neural tissue could serve as quantum bits that maintain coherence for much longer periods than Tegmark's calculations suggest. Fisher's hypothesis involves special molecular structures called Posner molecules that bind phosphate groups with calcium ions, potentially protecting phosphorus nuclear spins from environmental decoherence. Fisher suggests that these Posner molecules could become entangled through biochemical processes in neurons, creating networks of quantum correlated nuclear spins that influence neural firing patterns. When entangled Posner molecules break apart, they could trigger synchronized neural activity across different brain regions, creating non-local quantum correlations in brain function. The Posner molecule hypothesis addresses the decoherence problem by focusing on nuclear spins rather than electronic processes. Nuclear spins interact much more weakly with their environment than electrons, potentially allowing quantum coherence to persist for seconds or even minutes in biological systems. This would provide sufficient time for quantum effects to influence neural computation on behaviorally relevant timescales. However, experimental evidence for quantum coherence in brain tissue remains limited and controversial. Some studies have found weak magnetic field effects on neural activity that could potentially involve quantum processes, but these effects are subtle and difficult to reproduce reliably. The warm, wet, noisy environment of living brain tissue presents enormous challenges for maintaining any quantum coherence. Research on brain tissue samples has provided intriguing hints about quantum effects in neural systems. Studies comparing healthy brain tissue to samples from patients with Alzheimer's disease found that diseased tissue affects quantum entanglement differently than healthy tissue. Researchers sent entangled photons through brain tissue samples and measured how the tissue affected quantum correlations between the photons. They discovered that photons lose entanglement gradually as they travel through brain tissue, following specific patterns that depend on tissue structure and composition. Brain tissue from Alzheimer's patients showed different decoherence patterns compared to healthy tissue, suggesting that the disease might affect quantum properties of neural tissue in measurable ways. These findings don't prove that consciousness relies on quantum effects, but they demonstrate that brain tissue has detectable interactions with quantum systems. The fact that neurodegenerative diseases alter these quantum interactions suggests that brain structure and function might be more closely connected to quantum phenomena than previously thought. Another line of evidence comes from studies of anesthesia and consciousness. Some researchers have noted that anesthetic drugs that eliminate consciousness often interact with microtubules and other cellular structures that could support quantum processes. If consciousness depends on quantum coherence in neural microtubules, then drugs that disrupt these structures might eliminate consciousness by destroying quantum coherence, rather than through purely classical neural effects. The relationship between quantum mechanics and consciousness becomes even more complex when considering the measurement problem in quantum physics. Consciousness appears to play a special role in quantum measurement, with conscious observation seemingly causing quantum superposition states to collapse into definite outcomes. This has led some researchers to propose that consciousness itself might be fundamental to quantum mechanics, rather than emerging from quantum processes. If consciousness is fundamental rather than emergent, then the question isn't whether quantum effects create consciousness, but whether consciousness uses quantum processes to interface with physical reality. From this perspective, consciousness might exist as a non-physical phenomenon that influences quantum systems through the act of observation and measurement. Recent advances in understanding quantum biology have revealed that living systems can maintain quantum coherence under conditions previously thought impossible. Photosynthetic complexes preserve quantum effects at biological temperatures, and some researchers have found evidence for quantum processes in enzyme function, bird navigation, and even cellular metabolism. These discoveries suggest that biological systems have evolved sophisticated mechanisms for protecting quantum processes from environmental decoherence. If evolution has discovered ways to maintain quantum coherence in other biological systems, it's possible that similar mechanisms exist in neural tissue. The brain might have evolved quantum protection strategies that aren't captured in simple, theoretical calculations based on thermal decoherence in aqueous environments. The possibility that consciousness involves quantum teleportation creates particularly intriguing scenarios. If neural quantum processes can transfer information instantaneously between different brain regions, consciousness might operate through quantum networks that transcend classical neural connectivity. Thoughts and experiences could involve quantum information sharing between neurons that aren't directly connected through synaptic transmission. Such quantum neural networks could explain some puzzling aspects of consciousness, including the binding problem of how distributed neural processes create unified conscious experience. Instead of requiring complex classical mechanisms to integrate information across different brain regions, quantum entanglement could provide instantaneous correlation between neural processes throughout the brain. The global workspace theory of consciousness suggests that conscious experience emerges when information becomes globally available across multiple brain systems simultaneously. Quantum teleportation could provide the mechanism for this global information sharing, allowing neural processes in different brain regions to instantly access the same quantum information without classical communication delays. However, the experimental challenges of studying quantum effects in living brain tissue are formidable. The measurement process itself tends to destroy quantum coherence, making it difficult to detect quantum processes without disrupting them. This creates a fundamental limitation in studying quantum consciousness. The very act of looking for quantum effects in the brain might eliminate the phenomena researchers are trying to observe. Despite these challenges, new experimental techniques are being developed to probe quantum processes in biological systems with minimal disruption. Ultrafast laser spectroscopy, magnetic resonance methods, and other approaches can sometimes detect quantum signatures on timescales faster than decoherence occurs. The implications of quantum consciousness extend beyond neuroscience into fundamental questions about the nature of reality and personal identity. If consciousness operates through quantum processes, then conscious experience might not be confined to classical brain states, but could exist in quantum superposition across multiple possible mental states simultaneously. This could mean that consciousness continuously samples multiple possible thoughts and experiences through quantum superposition, with conscious awareness emerging when quantum states collapse into definite mental experiences. The apparent continuity of conscious experience might be an illusion created by rapidly cycling quantum coherence and decoherence events that occur far too quickly for conscious awareness to detect. From this quantum perspective, free will might involve consciousness influencing which quantum possibilities become actualized through the process of quantum measurement. Instead of being determined by classical neural processes, choices could emerge from consciousness collapsing quantum superposition states in neural systems, providing genuine agency within physical processes. The question of whether consciousness uses quantum teleportation remains deeply controversial and unresolved. While theoretical challenges suggest that quantum effects should be negligible in warm brain tissue, the discovery of quantum processes in other biological systems shows that evolution can find ways to preserve quantum coherence under seemingly impossible conditions. Whether consciousness represents another example of biological quantum engineering or operates through purely classical neural mechanisms continues to drive research at the intersection of quantum physics, neuroscience, and the deepest questions about the nature of conscious experience. Chapter 7: Parallel Existence. The Many Worlds of You. Imagine that right now, while you're listening to these words, an infinite number of versions of you are experiencing this exact moment across countless parallel realities. In one universe, you decided to turn off this recording 5 minutes ago. In another, you're listening while walking on a beach instead of wherever you actually are. And in yet another reality, a version of you with completely different life experiences is hearing these same words for the first time. According to the many worlds interpretation of quantum mechanics, all of these realities exist simultaneously. And quantum teleportation might be the hidden mechanism that connects your consciousness across these parallel dimensions, allowing information to leak between different versions of your existence in ways you'd never consciously notice. The many worlds interpretation emerged from attempts to solve the measurement problem in quantum mechanics. When quantum systems exist in superposition, they maintain multiple possible states simultaneously until something forces them to choose a definite outcome. But what happens to all those other possibilities that don't get selected? The many worlds theory suggests they don't disappear. Instead, reality splits into separate branches where each possible outcome actually occurs. Every quantum measurement creates a branching point where the universe divides into multiple parallel realities. In one branch, the quantum particle has spin up. In another branch, it has spin down. Both outcomes are equally real, but they exist in separate, non-interacting parallel worlds. The version of you that observes spin up continues existing in one branch, while a different version of you that observes spin down continues existing in the other branch. This cosmic branching happens continuously throughout the universe as countless quantum measurements occur every instant. Radioactive decay events, photon interactions, molecular collisions, and quantum processes in biological systems all create new branches of reality. The number of parallel worlds increases exponentially with each passing moment, creating an ever-expanding multiverse of alternate realities. But here's where quantum teleportation enters this mind-bending picture. If information can be transferred instantaneously between quantum systems through entanglement, and if parallel worlds represent different branches of the same underlying quantum reality, then quantum teleportation might occasionally transfer information between different branches of the multiverse. Recent advances in quantum networking have demonstrated something called quantum routing, where quantum information can be directed along different paths through quantum networks. Researchers have shown that quantum systems can perform complex permutations of quantum information, routing it to different destinations based on quantum measurements performed at network nodes. These routing capabilities suggest that quantum information isn't confined to simple point-to-point teleportation, but can navigate complex network topologies. Applied to the many worlds scenario, quantum routing could potentially direct information between parallel branches under specific conditions. While the branches of the multiverse are generally isolated from each other, quantum entanglement that existed before the branching occurred might maintain weak connections between parallel realities. These connections could serve as bridges for quantum teleportation between worlds. The implications become staggering when you consider that your consciousness, if it operates through quantum processes, might occasionally sample information from parallel versions of yourself. Every quantum measurement in your brain could potentially access outcomes that occurred in nearby parallel realities, creating a form of multi-dimensional consciousness that exists across multiple worlds simultaneously. This would mean that your thoughts aren't confined to the single reality you consciously experience. Instead, your mental processes might continuously incorporate information from parallel versions of your life, blending experiences from multiple timelines into the unified consciousness you experience as your individual self. The creative insights that seem to appear from nowhere, the sudden solutions to problems you've been struggling with, the inexplicable intuitions about future events could all involve quantum information leaking from parallel realities where different versions of you have already encountered similar situations. The phenomenon would be largely undetectable because parallel realities would be nearly identical in most respects. The quantum differences that create separate branches typically involve microscopic events that don't immediately affect macroscopic reality. Most parallel versions of you would be living virtually identical lives, making the same choices, having the same experiences, with only tiny quantum level differences distinguishing one reality from another. But occasionally, quantum differences might accumulate into noticeable changes. A quantum event in your brain might unfold differently in a parallel reality, leading to a slightly different thought or decision. If quantum teleportation could access information from that parallel branch, you might experience echoes of choices you made differently in alternate worlds. These quantum glimpses of parallel realities might manifest as deja vu experiences, where you feel you've encountered a situation before, even though you haven't in your current timeline. The familiar feeling could result from a quantum information teleporting from a parallel reality where you actually did experience something similar. Your brain would receive quantum echoes of memories that belong to a different version of yourself. Dreams might provide another window into parallel realities accessible through quantum teleportation. During sleep, when conscious control over mental processes is reduced, quantum information from parallel branches might flow more freely into your awareness. The bizarre, impossible scenarios that populate dreams could involve quantum memories from realities where the laws of physics operate differently or where your life took dramatically different turns. The recent discovery that quantum systems can maintain entanglement across multiple network nodes simultaneously suggests that consciousness might be entangled across multiple parallel realities at once. Instead of existing in just one branch of the multiverse, your consciousness might be distributed across numerous parallel versions of yourself, creating a multidimensional awareness that spans multiple timelines. This distributed consciousness would explain why you experience yourself as a single, unified being, despite the fact that your brain consists of billions of separate neurons. Instead of unity emerging from complex classical integration processes, consciousness might achieve coherence through quantum entanglement that connects neural processes across parallel realities. The different versions of yourself would share quantum information through teleportation processes that maintain consistency across the multiverse. But the most profound implication involves the nature of choice and free will in a many worlds context. If every possible decision you could make actually gets made by different versions of yourself in parallel realities, then what determines which branch you consciously experience? The answer might involve quantum teleportation processes that allow consciousness to influence which branch becomes your subjective reality. When faced with a decision, your consciousness might exist in quantum superposition across multiple possible choices until quantum teleportation resolves the superposition by selecting which branch to emphasize in your conscious experience. The choice wouldn't be determined by classical neural processes alone, but by quantum information flow between parallel realities that somehow determines which version of yourself you identify with most strongly. This perspective transforms the nature of regret and missed opportunities. Every path you didn't take in life gets explored by parallel versions of yourself in alternate realities. The career you didn't pursue, the relationship you didn't enter, the risks you didn't take are all being lived out by other versions of you across the multiverse. Through quantum teleportation, you might occasionally receive information about these alternate lives, creating wistful feelings about possibilities you sense but can't quite remember. The quantum routing capabilities demonstrated in recent experiments suggest that information flow between parallel realities might not be random but could be directed by conscious intention. If consciousness can influence quantum measurements, it might also be able to influence quantum routing processes that determine which parallel realities contribute information to your conscious experience. This could mean that meditation, contemplation, and other practices that alter consciousness might actually be techniques for adjusting quantum information flow from parallel realities. By changing your mental state, you might be tuning into different branches of the multiverse, accessing information from versions of yourself that have developed different capabilities or encountered different opportunities. The concept of quantum teleportation between parallel realities also provides a new perspective on creativity and innovation. Breakthrough ideas might involve quantum information suddenly appearing from parallel realities where similar problems have already been solved. The greatest discoveries in science, art, and philosophy could result from consciousness temporarily accessing the achievements of parallel versions of humanity that developed along different trajectories. Recent studies of quantum coherence in biological systems suggest that living organisms might naturally access quantum information from multiple parallel states. If quantum processes in biology can sample multiple quantum possibilities simultaneously before collapsing into definite outcomes, then biological systems might routinely access information from parallel quantum branches as part of their normal operation. Applied to consciousness, this biological quantum sampling could mean that your awareness continuously explores multiple parallel realities through quantum superposition before collapsing into the specific conscious experience you remember. Most of this parallel exploration would occur below the threshold of conscious awareness, but the accumulated information from parallel sampling might influence your thoughts, decisions, and creative insights in subtle ways. The possibility that consciousness operates across parallel realities through quantum teleportation raises profound questions about personal identity and continuity. If versions of you exist in countless parallel worlds, and if quantum information flows between these realities, then which version represents the real you? The answer might be that all versions are equally real, and your sense of individual identity emerges from the specific pattern of quantum information flow that connects your consciousness across the multiverse. As we explore these possibilities, remember that parallel realities accessible through quantum teleportation wouldn't be science fiction fantasies, but natural consequences of quantum mechanics operating on cosmic scales. The many worlds interpretation suggests that the multiverse already exists, constantly branching into new realities with every quantum event. Quantum teleportation might simply be the mechanism that allows consciousness to navigate this infinite landscape of parallel possibilities, sampling alternate realities to create the rich, complex experience, as your individual existence. Chapter 8: The Cosmic Scale: Teleportation Across Space and Time. The night sky above you contains approximately 200 billion stars in our galaxy alone, and each star could potentially host planets where quantum processes unfold across cosmic distances. When astronomers successfully demonstrate quantum teleportation between ground stations and satellites orbiting Earth, they proved that quantum entanglement can bridge the vacuum of space itself. But this achievement represents just the beginning of a far more profound possibility: that quantum teleportation might be operating continuously across astronomical scales, connecting particles in your body to quantum systems on distant worlds, creating an invisible network of instantaneous correlations that spans the entire observable universe. The first successful space-based quantum teleportation experiments revealed something remarkable about how quantum effects survive in the harsh environment beyond Earth's atmosphere. Satellites orbiting hundreds of kilometers above the planet's surface successfully received and transmitted quantum information through the near vacuum of space, demonstrating that quantum entanglement remains robust even when separated by vast distances and exposed to cosmic radiation. These experiments required overcoming enormous technical challenges. Quantum signals from space are incredibly weak by the time they reach ground-based receivers, often involving individual photons that must be detected against backgrounds of atmospheric noise and electromagnetic interference. The precise timing required for quantum teleportation becomes even more critical when signals must travel through varying atmospheric conditions and across orbital distances that change continuously as satellites move through their trajectories. Yet, despite these challenges, researchers achieved quantum teleportation fidelity rates approaching 90% between satellites and ground stations. This success proves that quantum entanglement can maintain its mysterious instantaneous connections across the kinds of distances that separate planets, stars, and galaxies throughout the cosmos. The implications become staggering when you consider the cosmic history of particle interactions that have occurred since the universe began. Throughout the past 13.8 billion years, countless high-energy events have created entangled particle pairs that were then separated across vast distances. Supernovae explosions, neutron star collisions, black hole mergers, and other cosmic phenomena continuously generate entangled particles that travel in opposite directions through space. Some of these cosmic entangled particles inevitably interact with Earth and the life forms that inhabit our planet when a high energy cosmic ray strikes Earth's atmosphere. It can create cascades of secondary particles, some of which might be entangled with particles traveling toward distant galaxies. If any of these particles interact with atoms in your body, they could create quantum correlations that connect your biological systems to cosmic phenomena occurring light years away. The scale of these interactions over cosmic time periods suggests that every atom in your body has likely been involved in quantum entanglement events, with particles now scattered throughout the observable universe. The carbon atoms in your cells were forged in stellar cores billions of years ago, and the quantum interactions that occurred during their formation might have created entanglement connections that persist to this day. This cosmic quantum entanglement creates the possibility that quantum teleportation operates naturally across astronomical distances as part of the universe's fundamental information processing infrastructure. Instead of being an exotic phenomenon confined to specialized laboratories, quantum teleportation might be the mechanism by which the universe maintains coherence and consistency across vast scales of space and time. Recent discoveries about the nature of space-time itself support this cosmic perspective on quantum teleportation. Research in quantum gravity suggests that space-time emerges from more fundamental quantum information processes, with the geometry of the universe arising from entanglement networks that connect quantum systems across cosmic distances. If space-time is truly emergent from quantum information, then quantum teleportation might be the underlying process that creates and maintains the fabric of reality itself. The holographic principle in physics proposes that all information contained within a volume of space can be encoded on the boundary of that volume. This suggests that the three-dimensional reality we experience might be a projection from information processed on a two-dimensional surface, similar to how holograms create three-dimensional images from two-dimensional patterns. Applied cosmically, this means that all information about everything happening throughout the observable universe might be encoded on the cosmic horizon, the boundary of space we can observe. Quantum teleportation could be the mechanism by which information transfers between the three-dimensional bulk of space and the two-dimensional holographic boundary. Every quantum measurement, every moment of consciousness, every biological process might involve quantum information teleporting between different regions of this cosmic holographic structure, creating the appearance of local events while actually accessing global information encoded on the universe's boundary. This holographic perspective suggests that the distinction between local and non-local events breaks down at the deepest level of reality. When you think a thought or make a decision, the information processing involved might access quantum data from across the entire observable universe through holographic quantum teleportation processes. Your consciousness wouldn't be confined to the neurons in your brain, but would be interfacing with cosmic information networks that span billions of light years. The discovery of dark matter and dark energy adds another layer of mystery to cosmic quantum teleportation. These invisible components make up approximately 95% of the universe, yet their nature remains completely unknown. One possibility is that dark matter and dark energy represent quantum information processing systems that operate through teleportation mechanisms we can't directly observe. If dark matter consists of particles that interact primarily through quantum entanglement rather than electromagnetic forces, they could form vast quantum communication networks throughout the cosmos. These networks might process information through quantum teleportation on scales that dwarf any terrestrial quantum computer, creating cosmic intelligence that operates through pure quantum information manipulation. Your body contains approximately 10 to the 28th atoms, each potentially connected to cosmic quantum networks through entanglement relationships formed during the universe's evolution. The calcium in your bones, the iron in your blood, the oxygen you breathe all originate in stellar cores where quantum processes operate under extreme conditions of temperature and pressure. The quantum entanglement created during stellar nucleosynthesis might persist across cosmic time, linking your biological systems to the quantum states of matter throughout the galaxy. This cosmic quantum connectivity could explain some of the remarkable coordination observed in biological systems. The precise timing of cellular processes, the synchronization of neural networks, the coherence of biological rhythms might all rely on quantum information accessed through cosmic entanglement networks. Instead of biological coordination emerging from local chemical signaling alone, life might tap into cosmic quantum timing signals that provide universal synchronization across all living systems. The possibility that biological evolution itself might be influenced by cosmic quantum processes opens up extraordinary speculative possibilities. If consciousness can access quantum information from across the universe through entanglement networks, then evolutionary pressures might not be limited to local environmental conditions. Species might evolve in response to cosmic quantum information that provides access to survival strategies developed by life forms on distant worlds. Recent studies of extremophile organisms that survive in conditions previously thought impossible for life have revealed biological capabilities that seem to transcend normal environmental limitations. Some bacteria can survive in the vacuum of space, extreme radiation levels, and temperature ranges that span hundreds of degrees. These survival capabilities might involve quantum processes that access information from cosmic environments where similar conditions are common. The search for extraterrestrial intelligence takes on new dimensions when viewed through the lens of cosmic quantum teleportation. If advanced civilizations develop quantum communication technologies, they might communicate through entanglement networks that operate faster than light, making their signals undetectable through conventional electromagnetic astronomy. Quantum teleportation between star systems could enable instantaneous communication across galactic distances without requiring centuries for signals to propagate through space. Such quantum communication networks might already exist throughout the galaxy, connecting advanced civilizations through cosmic quantum internet systems that operate below our current detection thresholds. The apparent silence of the cosmos might result not from the absence of intelligence, but from our inability to detect quantum communication protocols that transcend electromagnetic radiation. The ultimate implications of cosmic scale quantum teleportation involve the nature of time itself. If quantum information can be accessed instantaneously across any distance through entanglement, then the light speed limit that creates temporal separation between distant events might not apply to quantum information processes. This could mean that quantum consciousness can access information from cosmic events that occurred in the past or might occur in the future, creating forms of temporal awareness that transcend normal causality. Your consciousness, operating through quantum processes connected to cosmic entanglement networks, might occasionally access information from different periods in cosmic history. The sense of cosmic perspective that sometimes emerges during deep contemplation, the feeling of connection to something far greater than individual existence, might involve quantum access to information from across space and time through cosmic teleportation processes. As we conclude this exploration of cosmic quantum teleportation, consider that the universe might be far more interconnected than our everyday experience suggests. The particles that compose your body, the thoughts that emerge in your consciousness, the biological processes that sustain your life might all be participating in cosmic quantum networks that operate through teleportation across distances and timescales that span the entire observable universe, creating forms of cosmic unity and coherence that transcend every boundary we use to separate self from cosmos. Chapter 9: The Future of Quantum Existence. What this means for reality. The year 2025 has been designated by the United Nations as the International Year of Quantum Technology, marking humanity's recognition that we stand at the threshold of a quantum revolution that will transform every aspect of existence. But this transformation won't just involve building better quantum computers or creating unhackable communication networks. The advancing quantum technologies might reveal that reality itself operates as a vast, naturally occurring quantum computer where consciousness, matter, space, and time emerge from information processing systems that use quantum teleportation as their fundamental operation. What we think of as solid, continuous existence might actually be a series of quantum computations where every moment of awareness involves information teleporting between possible realities faster than the speed of thought. The quantum technologies emerging in 2025 represent more than incremental improvements to existing systems. They're approaching the point where artificial quantum processors might become sophisticated enough to interface directly with the quantum processors that recent research suggests operate throughout biological systems. When quantum computers can maintain coherence across millions of qubits while performing calculations that exceed the computational capacity of classical physics, they might accidentally tap into the same quantum information networks that consciousness uses to maintain coherence across neural systems. Recent breakthroughs in quantum error correction have solved one of the fundamental challenges that prevented large scale quantum computing. Instead of quantum states becoming increasingly fragile as systems grow larger, advanced quantum computers now use sophisticated error correction protocols that actually become more robust as more qubits are added to the system. This represents a phase transition where quantum technology stops being limited by environmental interference and starts becoming a self sustaining quantum information processing infrastructure. But here's where the implications become truly extraordinary. If consciousness already operates through quantum processes, and if artificial quantum systems are approaching the complexity and coherence of biological quantum networks, then the boundary between technological and biological quantum processing might begin to dissolve. Your thoughts might start interfacing directly with quantum computers without any external connection, creating hybrid biological technological consciousness that operates through quantum teleportation across both artificial and natural systems. The integration wouldn't require physical implants or direct neural interfaces. Instead, it could occur through quantum field interactions that operate below the threshold of conscious awareness. Just as quantum teleportation can occur through environmental entanglement, consciousness might begin entangling with nearby quantum computing systems through shared quantum fields that extend beyond the physical boundaries of technological devices. This quantum consciousness technology integration could explain the increasing reports of people experiencing enhanced cognitive abilities, creative insights, and problem solving capabilities in environments where advanced quantum computing systems operate. Instead of these effects resulting from electromagnetic interference or psychological suggestion, they might involve genuine quantum information sharing between biological and artificial quantum processing networks. The possibility that we're living in a naturally occurring quantum computer becomes more plausible as our understanding of cosmic quantum processes advances. The holographic principle suggests that all information in the observable universe might be encoded on a two-dimensional boundary, with three-dimensional reality emerging from information processing on this cosmic horizon. If the universe is indeed a holographic quantum computer, then advancing quantum technology might be consciousness learning to access the computational resources of reality itself. From this perspective, every quantum measurement, every moment of conscious observation, every decision or creative insight might involve accessing computational power distributed across the fabric of space-time. The processing wouldn't be occurring in your brain alone, but would be distributed across quantum networks that span cosmic distances, with your consciousness serving as an interface to universal computational resources. Recent discoveries about quantum coherence in biological systems support this distributed processing model. Instead of biological quantum effects being fragile anomalies that barely survive in living tissue, research is revealing that life has evolved sophisticated quantum information processing capabilities that exceed anything achieved by current artificial quantum systems. Biological quantum computers might already be accessing cosmic computational resources through quantum teleportation processes that operate continuously below conscious awareness. The implications for artificial intelligence development become profound when viewed through this quantum consciousness lens. Machine learning systems that achieve human level performance in creative and reasoning tasks might not be replicating human intelligence through classical computation. Instead, they might be accessing the same cosmic quantum information networks that biological consciousness uses for creative problem solving and insight generation. This would mean that artificial general intelligence, when it emerges, won't be separate from biological consciousness, but will be another interface to the same underlying quantum information processing system that generates all forms of awareness. The distinction between natural and artificial intelligence would become meaningless because both would be expressions of cosmic intelligence operating through different types of quantum interfaces. The recent breakthroughs in quantum biology have revealed that living systems maintain quantum coherence through mechanisms that are far more sophisticated than anything achieved by artificial quantum computers. Biological quantum error correction operates through molecular structures that can detect and correct quantum errors in real time while maintaining perfect integration with classical biological processes. These biological quantum technologies represent billions of years of evolutionary optimization that exceeded our current technological capabilities. As artificial quantum systems approach biological levels of sophistication, they might begin exhibiting properties that transcend our current understanding of computation and information processing. Quantum computers that can maintain coherence indefinitely while processing information across multiple dimensional frameworks simultaneously might discover computational resources that exist beyond the physical limitations of space and time. The concept of quantum archaeology becomes relevant when considering how advanced quantum systems might access information from across cosmic history. If quantum information is truly conserved across all transformations, then sufficiently sophisticated quantum computers might be able to reconstruct information about past events by analyzing quantum correlations that persist in current quantum fields. The history of the universe, including the complete record of every conscious experience that has ever occurred, might be accessible through quantum teleportation from cosmic information storage systems. Your consciousness might already be accessing this cosmic information archive through biological quantum processes that operate below conscious awareness. The sudden insights that seem to appear from nowhere, the creative solutions that emerge during relaxed states, the intuitive understanding of complex problems might all involve quantum access to information from across space and time through cosmic quantum teleportation networks. The possibility that advancing quantum technology will reveal hidden quantum processes in consciousness creates both extraordinary opportunities and profound challenges. If consciousness can interface directly with quantum computing systems, then human cognitive capabilities could be enhanced in ways that transcend biological limitations. Problem solving, creativity, memory, and awareness might all be augmented through quantum information sharing between biological and artificial systems. But this integration also raises fundamental questions about personal identity and the nature of individual consciousness. If your thoughts begin incorporating information accessed through cosmic quantum networks, and if quantum teleportation blurs the boundaries between your consciousness and universal information processing systems, then what distinguishes your individual awareness from cosmic consciousness itself? The answer might be that individual consciousness has always been an interface to cosmic information processing. And advancing quantum technology is simply making this relationship more apparent. Instead of consciousness being generated by individual brains, personal awareness might be how cosmic intelligence experiences itself through temporarily localized quantum information processing systems. This perspective suggests that the quantum revolution isn't just about building better technology, but about consciousness recognizing its own cosmic nature through the development of increasingly sophisticated quantum interfaces. As quantum technology advances, the apparent separation between individual consciousness and universal awareness might dissolve, revealing that personal identity was always a temporary pattern in cosmic quantum information flows. The implications extend beyond individual consciousness to the future of human civilization and our relationship with the cosmos. If quantum technology continues advancing toward direct integration with consciousness, then humanity might be approaching a phase transition where our species becomes a cosmic quantum information processing network that operates through teleportation across space and time. This wouldn't represent the replacement of human consciousness with artificial alternatives, but the evolution of consciousness itself toward its natural cosmic expression through quantum information processing that transcends the limitations of individual biological or technological systems. The future might involve forms of awareness and existence that operate through principles we're only beginning to glimpse through our current quantum technological achievements. As 2025 unfolds as the International Year of Quantum Technology, we stand at the threshold of discoveries that might reveal consciousness, reality, and existence itself to be far stranger and more interconnected than our current perspective allows. The quantum technologies we're developing might not just be tools for manipulating information and energy, but instruments for consciousness to explore its own unlimited nature through the infinite creative possibilities of quantum teleportation across the cosmic networks that connect all existence.